other forms of factoring. So let's say that I have something that looks like x squared over x minus 1 times x plus 1 quantity squared. Now, again, my real goal here is to integrate this rational function. That's our overarching goal. But the intermediate goal is going to be to look at this and say, okay, I've got a rational function in here, and it doesn't look like the u substitution or anything like that is going to work. I need to rewrite this rational function. And so we are going to rewrite the rational function using partial fractions. All right, now that means that I'm looking and I'm focusing strictly on the x squared over x minus 1 times x plus 1 squared. So I'm completely ignoring the calculus. I'm not worried about the integral or the dx. I just want to focus on rewriting this rational function. Okay, so step number one was to make sure that the fraction is proper. Now, I see an x squared on the top, so the degree on the top is 2. In the denominator, I have to sort of think ahead in my brain and think, okay, if I multiply this denominator out, then I would have a degree 3 polynomial. Okay? And so this is already a proper fraction. Okay? The degree of the numerator is smaller than the degree of the denominator. So step 1, make sure you have a proper fraction. Step 2, factor the denominator. Cool. Somebody has already factored this denominator for us. Factor the denominator, check. All right, our next step is to write our fraction as a sum of partial fractions. So we've got x squared over x minus 1 times x plus 1 quantity squared. And here's where we need to pay attention. Okay? This guy is factored. The denominator is totally factored. But what I notice here is that while I have completely linear terms, there's no x squares in here, everything is factored down to x plus or minus some number, I have a repeated term. So a repeated linear term. If we did not have a repeated linear term, if we just said x minus 1 times x plus 1, then I do a over x plus 1, a over x minus, or b over x minus 1. Okay? And I would write those down. With a repeated linear term, what I want to do is to write down my form in the following way. My individual term will have an x minus 1, that's my unique term. So I have a over x minus 1. And now I look at the second term, this repeated term here. And I start out by writing down x plus 1 in the denominator. And I'll have an unknown on top, so I'll go with b on that one. In order to adjust for the fact that this guy is repeated, I have a third fraction. This third fraction tacks on the additional linear term. And I have an unknown c on top of that. Okay. So,
Did that have a bx up there too?
That's a good question. The answer is no. Because on this term here, on both of these first terms, we want our numerator to be a degree less than the denominator. So this guy should always just be an unknown number.
So in that case, there should be a cx, right?
So that's the next question here is, what about c times x? And the answer here is no, but the reasoning is slightly different. And the reasoning is that going from here to here, we're bumping up our degree by 1. So we're really only giving a linear version of a new term here. So this is still just a plain number CFF. And that may be a little bit upsetting. Try it out a few times and see if it works out okay for you. Okay, so these are our terms, and so our next goal would be to find a common denominator over here on the right side. So we'd have a times, we need a common denominator of x minus 1 times x plus 1 squared. So we have a times x plus 1 squared over x minus 1 times x plus 1 squared. Plus b, we need an x minus 1 and an x plus 1. And then on the bottom we have x minus 1 times x plus 1 squared. And for the c, we need just an x minus 1 to make the bottom be common with everything else. Alright, our left side is still x squared over x minus 1 times x plus 1 squared. Okay. Common denominator, I can combine all my terms on the right-hand side. I can then clear out the denominators, which leaves me with an x squared on the left side. On the right side, we've got a times x squared plus 2x plus 1 plus b times x squared minus 1 plus c times x minus 1. And I did two steps there at the same time. I combined my fractions on the right side and then I cleared out the denominator. And I expanded out some of my terms. Alright, I still need to finish expanding out these terms, so I've got ax squared plus 2ax plus a is plus bx squared minus b plus cx minus c. Alright, so combining some terms, I'm going to collect together my x squared terms. I've got an a plus b times x squared. I've got a 2ax plus cx, so that is plus 2a plus c times x. And then my constant terms, a minus b minus c. All right. Any questions about setting that up right there? Okay. So on this equation, I need for my x squared terms on the left and the right to be the same. So for the x squared, I've got a 1 as my coefficient on the left, and I've got an a plus b on the right, so 1 had better be equal to a plus b. On the x term, on the left side, there's no x term, so I have a 0 on the left side. And on the right side, I've got 2a plus c. And for my constant term, on the left side, there is no constant term, so I have 0 constants on the left. And on the right side, I've got a minus b minus c. So now I've got 3 equations and 3 unknowns, which means that I'm going to need to solve one equation for one letter, plug it into the others. I'm going to see if I can work it out. Okay, so the moral of this story is, if we have a repeated term, when we set up our partial fractions, that repeated term shows up once in one fraction, twice in the second. If this had been a cubed, we would have had another term on here, d over x plus 1 raised to the third. Okay, so you should check this. You should check that your final answer is, if you work this out, a should be equal to 1/4.